everybody. This is the second practice problem for this section, 5.1. And for this problem, we're going to use a left Riemann sum, and I decided to change the problem and make it have 8 rectangles to approximate the area from 1 to 5. I want you to see what happens when the curve goes below the x-axis. So we're going from 1 to 5. We want 8 rectangles. Again, if I just counted over the whole numbers here, I would have 4 rectangles. So I'm going to cut each one in half. The fact that problem number 1 and problem number 2 both have a width of 1/2 is just a coincidence. This is a left Riemann sum, which means that the height of the rectangles are going to come at the left, where the left side meets the curve. If I write this first triangle, the left side of the rectangle is at 1. The next rectangle is at the left side at 1.5. Then at 2, 2.5. Then at 3, at 3.5. Now I want you to see at the next rectangle, the height is at 4. Well, at 4 it's 0, which means that this rectangle does not have any height. And then the next rectangle is at 4.5, which goes below the x-axis. So we now want to find the area of each one of these. So we are finding the left Riemann sum at 8. The width of all the rectangles is 1/2. And we are going to find f of 1 plus f of 1.5. So notice I'm taking the leftmost x value of the interval, the subinterval. F of 2, f of 2.5, f of 3, f of 3.5, I hope I don't run out of room, f of 4, and f of 4.5. And so at f of 1, the height is 7. At f of 1.5, the height is 6. At 2, it's 5. At 2.5, it's 4. At 3, it's also 4. At 3.5, it's 2. At 4, it's 0. So I know it's weird to have a rectangle with a height of 0, but that's what's happening here. And then at 4.5, we went below the x-axis, which means that the height of this rectangle is -1. Again, I know it's strange to have a height that's negative, but anytime the curve goes below the x-axis, we want to subtract off that area. So now when we add these up, let's see, here we get 18, 22, 26, 28. So 28 minus 1 is 27. So we'll get 27 divided by 2, or 13.5.